Okay, we're live. So, Vivek, do you want to start?
Yeah. Yeah. Hi, everyone. Thanks for joining. This is our monthly Bionics chapter meeting, Bionic design chapter meeting. The goal here is to invite speakers who are doing interesting, exciting work in Bionics for a low-cost version of Bionics, not the $50,000 Bionic hands. And so this week, we are very lucky to have Xavier Grosjean, and I'm sure I'm killing the pronunciation. Xavier, apologize. And he's from e-NABLE France, and he's going to talk about some very interesting work he's doing in adapting an existing design. So with that, Xavier, please, the
Okay,
floor
thank
is
you very
yours.
much. Thank you very
Thanks.
much. No problem with my name. Maybe I will start with a short demonstration that will hopefully work. Let me try to share. I need an approval to be able to share, actually.
You're saying you don't have permission?
No, I do now. Thank you.
Okay, good.
Awesome. So let me share. Okay, so here is the hand that I will present. I'm plugging just a USB battery. You see it, right? Okay, so there is a short initialization routine, and then I can connect my phone through Bluetooth. Connecté. And I can talk to it to connect, actually. There are a few predefined positions here, positions and movements, actually. So you can either click on the screen or you can talk to it. Position ouvrir. Position fermée. Position...
And it speaks French.
4. Yes, well, it speaks English also. It depends on the language of your phone. I've tried it in English and it's working, but it's a bit complicated to switch the language on the telephone, because then the speech recognition won't work for a while because it needs some update. Or so. I haven't mastered all the mysteries of the voice recognition, but it can work in English or other languages. The application needs to be adapted for that.
Please continue.
I have adapted the application for English as well. Position viens ici. So that's a movement, actually, that is pre-programmed. Position gratte. Another movement. Position love. Position OK. And that's it.
So I have position thumbs up.
Yeah, you can have variants, but I think position OK is the same as position thumbs up. That would work too. I have prepared a few slides as well. So I will tell you why I started working on this project, what I wanted to achieve, how it's done, and what is done and what is not done yet, and what could be next. So I've been 3D printing since about 10 years, I guess, and I've joined e-NABLE in 2019, I think. And since then, since my hobbies include electronics, I've tried to find interesting robotic projects. And when I joined e-NABLE, obviously, I tried to find robotic hands. And I've seen a lot of promising projects on GitHub or other repositories, but the only one that was really advanced and complete with good documentation for anyone to build it was the Hackberry from Japan. I didn't build one from scratch, but I helped someone from e-NABLE to build one. And I thought it was a bit complex, a few pieces are difficult to print and a bit fragile. And also the electronic is a bit old now. And I know that somebody in France worked on a new version of the PCB to include Bluetooth and stuff like that, but I don't think it was finalized. And also there were newer 3D designs, like the kinetic hand by Matt Botel, which I thought was better and more appropriate for something very affordable because it's easy to build. So the goals I had for this project was to be for it to be very complete with everything available for assembly and development and also participation because it's open source. I wanted it to be very affordable. I wanted it to be easy to build and easy to find all the pieces, the needed pieces, and without any fragile 3D parts. And I also wanted to allow to have it allow experimenting, for instance, experimenting sensors and various control solutions. So for the 3D model, as I said, the kinetic hand looked pretty cool and was very easy to build and robust. But unfortunately, in my first prototypes, I made several prototypes, such as these. It's a bit fuzzy. Very quickly, I saw that the TPU hinges were requesting too much force from the small servo motors. So the force was mostly wasted in folding the fingers, which is why I replaced the TPU hinges with print-in-place hinges that require almost no force to bend. I've printed a big one that I can show you maybe, as you can see. So it needs to be pretty accurate because the precision, the tolerance are very tight, so it does not scale well. You have to redesign the stuff. But with a Fusion parametric file, it's not much work actually. And as you can see, it does not need any force, or maybe that's just the gravity to fold. Of course, there is an inconvenience, which is that it will not unfold the finger when released. So I had to put another wire to be able to pull the finger back open, which would not be a problem for the servo motors because they can rotate one way or another, obviously. And it required designing pulleys with two different diameters because the length of wire to fold the finger is not the same as the length of wire to unfold the finger. The electronics, I chose an ESP32 board because they are very small, very powerful, more powerful than most Arduinos, but they have less input and outputs. But I didn't need that many input outputs. And it comes with Wi-Fi and Bluetooth support. So I thought it was pretty interesting. I also have designed a PCB. At first, the PCB was equipped with current sensors because I wanted to monitor the current drawn by the motors I was hoping to be able to control the force applied by the motors, but I never really had something working well. I think it's a mix between a hardware issue and a software issue because, for instance, when a motor starts, it will draw a lot of current, even if there is no opposition to it. So it's not an easy problem to tackle. So I've designed another PCB, whereas in which I didn't put any current sensor, but connectors these pins, which allow to connect different how did I call that, shield boards, on which you could try new designs or new components or new sensors or anything. They are basically linked to the input and outputs of the ESP board, and these ones are linked to the motors, so that you can put some circuitry between the ESP and the motors. And the servo motors, I bought cheap ones from Amazon, I think. And I didn't know that they could come in several form factor for the same reference, AMG 90. So the ones I got was the first kind, and the second kind, you can see that the top here is not the same height. The overall height is the same, but the shape is a bit different on the top. And obviously, I designed the 3D part with the motors I had, but some other people who built the hand had this kind that I never could find on Amazon, unfortunately, because I would need some to adapt the design of the 3D part. So that's the pain point when you build one. I know at least, I think, 4 person who built one, and 2 of them had this kind of a motor, but they could adapt, but it was a bit clumsy.
So the one with the red arrow is the correct one.
No, the correct one is the first one. The red arrow is to show the difference in height.
I see.
In the top here. This is shorter here than here, and this is shorter here than here. So the overall is the same, but it's a bit different
Okay.
near the top. Yes, and unfortunately, when you order them on Amazon, you can get one picture but receive another motor, because I tried to get some to adapt my 3D design, and the picture was showing this, but what I received was this.
You know, Xavier, this looks like such a good job you've done here that it might be worth sending the relevant information to Jeremy Simon. He might stock up on those, so that people could order the right device confidently from 3D Universe.
Ah, that's interesting. I never thought of that. Yes, of course.
And probably at not at an increased price, because he'd be able to negotiate a bulk purchase.
Maybe, but on the other hand, it would not be very difficult to adapt the 3D design so that it could fit both motors. The problem I had is that I was never able to get these kind. But
I see. Okay.
if I could, I would just adapt, and I'm pretty sure it's possible to accommodate both form factors. Yes.
Okay.
I'll recommend too. I've done similar projects where I actually designed in my own housing into the part and actually took the guts out of the motor. So that's something to consider too.
Yeah. Maybe it's a more complex operation for everyone to build, having to do that. It might be a bit more complex, but it's interesting, and especially to maybe gain some real estate, because you can have something much more tight around the motors, probably. The firmware, it's written in C++, and it's structured to easily add new positions or movements. It's pretty easy to do so. The Android application is in Java, and there is no iPhone application for now. Well, there is a prototype that I've seen working, but I did find a volunteer to make the iPhone application, because I could not, and I have no news. I know that he started his own business, so he's very busy. But yeah, there is some work in progress, but it's been a long time since I've heard. I just saw a prototype working. The nice thing about the voice activation is the voice control is that there is no learning, there is no muscle that you would have to learn to flex if using sensors. But of course, at least for now, anyone can give orders, send orders to the hand, which can be, of course, a big issue. But I think it is possible to have the application recognize the voice of the owner of the hand. I have not worked on that, but yeah, I think it can be done. I wanted also to pursue some AI stuff to recognize the voice, maybe with an onboarded system, so that an application over a phone would not be necessary. But that's a big project in itself, and I couldn't do that. So what is done? The documentation is pretty complete and allows assembling a working device. I've heard of several people do it. Including a 73 years old French guy who contacted me after he had done almost everything. He had only trouble uploading the firmware because he had never done that before. But all the electronics and 3D printing and stuff, he was able to do it and build it. So I was pretty happy. The device is very affordable. It's around $60, I would say. Of course, if you buy in bulk, it can be cheaper, but maybe not everyone will want to build 10 hands. All the files are available for the 3D models and PCB, the firmware and application, except the step files because they need some cleanup, I guess, but they could be made available easily because they are much easier to work with, to make modifications, of course. Which is in the not done part. The step files need to be published, and also the documentation is not complete about the new PCB, the one with connectors to put shields or extensions on it. This needs to be done yet. And what I had in my bucket for next iterations, but I have had no time to work on this for a while, would be the on-the-air firmware updates, being able to update the firmware through Wi-Fi or Bluetooth. For now, it's done through USB. It's really easy. You just drag and drop a file, or no, maybe it's a bit more complex than that. It was another version of the ESP that allowed to do that. But it's not very complex, but out here would be nice. Secure the Bluetooth access so that not just any phone can connect to the hand. The voice control, as I said, should ideally work only with the noise voice. iPhone application in progress. Firmware needs to be able to save some configuration and maybe some custom movements or custom positions that could be added through the application. The configuration could involve the calibration process, because depending on how tight the wires are mounted, the calibration might be different. The calibration is the start and end position of the motors for each finger. I didn't work on the silicon pads for grip, so the fingers don't have much grip for now. And also, if some wire tensioners could be mounted on, in the fingertips, it would be great, because it would make calibration and also building easier. One big inconvenience is that because of the space needed by the motors, and also the precision, the tolerance for the hinges, both for the hinges to be able to fold and for the hinges inserted in the fingers and in the hand, the 3D models cannot be scaled. So they would need to be, well, apart from the motor space, obviously, which cannot be reduced much, But the 3D models would have to be generated at different scales if we wanted to have several sizes. And for the motor, I have a project to work on a solution with only one motor. Of course, that would give less control on the fingers, but it would be close to the non-motorized solution where everything closes at once. I think it would be interesting. The wrist gauntlet needs to be adapted. Something I realized very late in the project is that the grip is not that great because the thumb is not opposed enough to the fingers. It's on the side, a bit too on the side, which this was fixed in the hand for the kinetic arm, where the thumb is really opposed to the finger and gives a good grip. So I worked on a small modification of the hand, but I haven't tried it, to turn the thumb a little bit inward. So the green solution here, you can see that the thumb is a bit more inward, the thumb socket. I'm not sure it's enough, and I think my next project would be more working with the kinetic hand of the kinetic arm, and with one big servo motor, so that it can be resized to fit smaller hand needs, I guess. And I think we're done. So yeah, it's pretty affordable, and I think it's more a device to explore solutions, sensor solutions especially, and control solutions. Then it's more that than a hand that could be used by someone missing a limb. But maybe it's worth trying.
Well, I have a question, but I'm going to raise, so I'll raise my hand and ask the question. So how physically strong is the grip on this?
It's strong enough to hold my hand, and let me, maybe I'll try to show you, but it's not very strong. Stance, let me reconnect. Okay. Position close. It's holding. Even with the thumb not much opposed, it's holding, but then my hand is big too, but yeah. And here it's not even, yeah, I could have positioned my hand a bit better to be also, yeah.
All right, well, that's impressive. Your grunts are impressive. So, I wonder why you think it's only for research purposes. Why couldn't it be turned into an inexpensive motorized hand for amputees?
It's a bit big, I think, if you compare with my hand, for instance. It's a bit bigger than my hand.
Okay.
Not that much actually, but a little bit.
Yep.
But yeah, it maybe it's worth trying. The gauntlet does not need much adaptation because I haven't touched these parts, but it would maybe need to accommodate a battery or something like that. Yeah, probably it could be tried.
Okay, another question along those lines.
Sure.
So there's an external battery, which
Yes.
is sitting on the table there.
Yes.
And it's probably adequate for some large number of gestures, but that's a perfectly good design you have there. To what extent is the phone an essential component? Could there be, for example, an actuator button on the hand that would trigger these gestures, or do you need the computation of the phone?
No, there's no computation on the phone. The phone only sends commands through Bluetooth, and the commands are just words like close, open, and things like that. So there's no computation other than voice recognition. So absolutely, you could have, especially with the new boards. I don't have one equipped with with the pins here, but
Mhm.
with this board, you could just solder switches
Yep.
and obviously modify the firmware because it's not reading the inputs of the ESP, but you could do that. Yes, absolutely.
So that's good news. Let me just say, if you think about this as a device for real users, it would probably need to be made water resistant, if nothing else. And you could certainly imagine 5 buttons for the 5 gestures, but you might find it interesting to think about a few other possibilities. When you, at one point, you were trying to sense finger position. I gather you don't have anything like right now, but I could imagine that tapping either on individual fingers using the finger motion as your actuator device, or patterns of taps would be a way to subtly be able to signal the various gestures. I'm thinking that if you're trying to do something in 2 hands, it might be interesting. For example, if you're going to be trying to lift something, you would want your 2 hands in this posture. If there was a delay, so you said click, click, the hand closes, and now you have time to get the 2 hands in position in order to do it.
Yep.
But detecting patterns of taps might be an interesting way to not burden the mechanism with sensors and to now restrict control to people within tapping distance of the hand, namely the user, and not his
Yes.
prankster friends.
Yes, that's a very interesting idea, and I think the ESP is capable enough in terms of I don't know reading input, reading speed, or stuff like that to maybe measure the time between taps to decide if it's a double tap or triple tap or whatever, or two distinct taps. I think it's the board is really powerful enough to do that. So yes, with firmware adaptation, I'm sure it can be done. Also, something interesting.
Excuse me, sir. I have a
Sure.
meeting in 1 minute. I'm very excited and interested. I left my email address, and I would like to discuss. I'm from the French chapter as well.
Okay.
John
Excellent.
knows me.
Patrick,
Sure.
pleasure to
John.
meet you.
Hello, John.
Nice to meet you.
Sorry, but there is a conflict of meeting. Thank
Okay,
you.
no,
Good.
no problem. Okay, I'll get
Good
your
job.
your
Good
email.
job.
Thank you
Thank
very
you.
much. Merci.
Bye.
Thank you. Bye. Yes, I wanted also to show you the left hand because I show you the right hand, and you can just print symmetric stuff. So I don't know if you see. No, it does not show up. There are little numbers engraved on the motor covers. Yes, like 3, 4. So obviously on this hand they are reversed because it's just the same files but printed after doing a symmetry. And the board is the same board, but it's just upside down. So you solder the connectors on the other side and everything works. And I don't remember. Yeah, in the firmware, there is a version for the left hand and a version for the right hand because all the start and end positions and motor directions need to be reversed. So basically, it's the same firmware. There's just a flag that says left hand or right hand. But yes, it would be interesting to try to adapt more useful ways to control it and then see if it can really help someone. Of course.
I do have another question. I also want to make sure that we give Majara a chance to present. But it's a very sophisticated and yet simple design that you've done, and that's the sweet spot. The mechanical hinges could be huge for the e-NABLE community. And so your creation of pullback cables as well as pull forward cables is really interesting. It would be, I think it would really be great if somebody took what you've done to the kinetic and the mechanical joints and made it easy to do parametric expansions and contractions, and figured out a way in which, as we do, elbow action could open as well as close the hand. That, I think, could become a new kinetic arm that would be widely adopted because you've gotten rid of the TPU, etc. So that's just with regard to the scaling issue, and then I'll pause, I guess. I do see that it's big because you've had to cram all of that there, but it looks like the servo size is the limiting factor.
Oh, yes, definitely, yes.
Do servos come even a little bit smaller so that it could fit smaller hands?
I think there are I think I've seen smaller ones, but they will have less torque, less force,
Right.
so it can be an issue. But I think if I cut, they have small. Let me go back to. I thought it could be interesting maybe to cut these parts and then
Yes.
stick them 2 by 2, and we could probably save some space by doing that. But one issue also is that I wanted the pulleys to be aligned with the holes for the wires, so that there are no need for extra pulleys, or they do not. There is no friction anywhere. I could not avoid it for the thumb, obviously, so it's a bit more complex here because you have two pulleys for the two cables. So yeah, to keep it simple, it's easier if the pulleys are facing the wires, but it also takes more space because otherwise you could cram the motors very close from each other, but then you would need some kind of. But it's probably worth trying because nylon against PLA does not. There's not that much friction, so maybe maybe I should just try to stick them all together and have holes in the plastic to drive the wires. Yeah, this is worth trying.
It would be good to know. It's true.
Absolutely, yes.
It does occur to me again because the applicability, actually putting this into and on the hands of users, is such an important issue for e-NABLE. The mechanical hinges, as I say, I think are huge, and the pullback cables could easily be spring-loaded, so that way you'd be able to move your arm around.
Yeah.
Okay.
Yeah, there's no need for much force to fold back
to open it. That's right.
One of the prototypes I've done first was using one big servo. So if we can trade the independence of each finger for one big servo, we can of course scale the hand much more.
Yes. It's really beautiful work, Xavier. Thank you.
Thank you so much. Thank you very much.
Vivek, Jonathan, do you, Majar says he's going to be 5 minutes yet, so we do have time for conversation. Do you have any comments or questions?
I have a quick question. So, Xavier, are you going to? There's no force control here, right? It's just on off, basically.
Yes. Yes,
Okay.
you can control the end position. You can fold halfway or whatever, but yes, there is no force control. If there is an obstacle, it will try to go to the position you selected.
And is it true that it's not that big a deal? I mean, in the prosthetics community, it's more important to just get the basic grip versus having force control.
Yeah, and it's still
know.
wires, so it won't hurt you. I mean, if you see, if I put my hand and it tries to what do you say, to squeeze it,
Crush.
it won't hurt me because it's not strong enough anyway.
Right. Okay.
But ideally, yes, I wanted to have some control of that, but I could not manage that.
Yeah, I was thinking the reverse, where you want to pick up an egg versus lift a spade.
Yeah, exactly.
Yep.
Yes.
Okay. Oh, this is fabulous.
Thank you so much.
In terms of lining up the servos, if that works, that would be great. Jonathan's point is an interesting one. If
Yes.
you remove the housings and then created wells that were themselves the position and angle was parametrically adjustable, that would probably give you a lot of room for maneuver and to make the whole
Yes.
thing scalable.
Yes, absolutely. I haven't tried to take one apart, but I have extra servos, and maybe I have a look. But yes, probably we could win some space by doing that. That would be great.
So how are you marketing this, if you will? Obviously, you're presenting here, and we have millions of people watching this webcast. How else are you letting the world know that this is out here?
I'm not really good at that. I think I posted a few messages on Facebook on the e-NABLE groups, French e-NABLE groups. I think I posted on the hub. I wrote a post for the hub, and I think that's mostly it. Also, I bring it when I have when I'm involved in some meetings for e-NABLE or for associations where e-NABLE is invited. I usually bring it to be able to demo it, but that's it.
So for a full prosthetic hand, you could move the servos back into the arm, right? The forearm, versus trying
Yeah,
to put them all into the
that
hand.
also could be done, or it could be yeah.
That's true.
Yeah, if there is enough space, that will depend on the forearm, the presence of a forearm or not.
Right.
But yeah, absolutely. And so I have a GitHub repository. I don't know if you are familiar with GitHub. So it's a public repository that can be accessed by anyone. And there is the 3D files, the application. There are a few videos with the early prototype, which was pretty fast actually. I didn't remember that it was fast.
Nice.
Is not to rush this, but is Mazhar ready to go?
Of course,
We have
of course.
20 minutes. No. I just wanted to see if he's available.
I think it looks like he just transitioned from the phone he was listening in on while he traveled to his computer. So as far as I think he's not quite here yet, but he did tell us that he was about to get here.
Okay. And
no, so keep going.
So yeah, just one more thing. The documentation is in the wiki section of the GitHub repository, and with everything needed to print the knuckles and all the parts, and how to assemble and how to upload the firmware, etc.
Would you be able to share this presentation, Xavier, that we can put up on the website, the e-NABLE portal, or
the slides?
Yes.
Yeah,
oh yes,
the
of
slides.
course. Oh yes, of course. Yes, sure.
And Vivek, for that matter, you will soon have the recording, which you can put into the, you can clip it and put into the same thing.
Yep.
So Xavier, you're obviously a very sophisticated hobbyist and engineer. And I think that's where your passion is. You don't seem as eager to find a user to do it as to continue to develop it. That's fine. So I've got some questions around that. This adaptation of the hand to of the joints to a mechanical hand and making that parametrically scalable is an immediate activity that actually takes the electronics out of the picture, but could potentially make that a much more accessible device to enable volunteers all over the world. Do you have and yet the parametrics would be tricky there, because as you say, the tolerance is blah, blah, blah. Although if the joints were made smaller, they might be constants that even if with a smaller or a larger hand. Anyway, figuring all of those details out, is that something you are likely to do, or are you likely to continue on your current wonderful trajectory?
Yeah, it's an interesting project. So I may try to solve some of these issues. It depends on, sometimes I have free time on my hands, and sometimes I don't have that much free time on my hands. But yes, it would be interesting to solve these issues for a non-motorized hand. I've tried to think a little bit about it, but so far I haven't found a way to fold the fingers back using a wire, but maybe using a spring or latex band or something like that would just work. I think it's yeah, it's interesting to try to solve these. The parametric, I'm not sure. It's pretty easy to do with Fusion, but of course for most makers, they don't have Fusion, or they don't know how to use it. So
well, but Fusion is available for free, and with
yes, it
Fusion
is.
you can make sliders. So if you were to do that, I think it is reasonable to imagine that a Fusion user would, you know, with simple instructions, they would open it, they would activate your little adjustomat
Yeah,
panel, and they
yeah,
wouldn't have to
probably.
master Fusion. They're just using it as their parametric adjuster.
Yeah, maybe the
Right.
designs would have to be adapted, because it's not just let me show you on this. So the
Xavier,
hinge, yes.
sorry to interrupt, but Mazar is ready
Oh
to
yeah, sure,
go.
sure,
And
sure. I don't want to take all
we
the
have
time,
only
of course. Yeah,
17,
yeah, but
15
let's talk
minutes.
about that
Sorry,
later,
no.
John. Yes, of course.
Okay. Thank you all. Thank you,
Thank you. Thank you very
Xavier.
much. Thank you.
Terrific.
Thank you very
Mazar, nice
much.
to see you.
Mazar, floor is yours.
You're on mute, Mazar.
Okay. Hi.
Hi.
How are
Hi.
you?
Good.
Are you fine? Thank you. I'm Mazhar Habibi from Afghanistan, and currently I'm ungraduated from university, still doing my studies and university, and I will present my prosthetic hands that I made, and we'll see. Okay. Unfortunately, I didn't got ready for any PowerPoints or presentation, but I will show you the arm like this. Okay, I use a servo motor and foot like this. Yes, and let me show you some picture of it. But do you have? You can see.
Yes.
Yeah.
Oh wow.
I use from the some 3D printed, just palm is just 3D printed, and use a bicycle chain for the fingers to make it
Let me make sure everyone
strong.
heard that. Did you say a bicycle chain?
Yeah, bicycle chain to make it stronger. Unfortunately, because of lack of professionals in 3D designing, or maybe engineers in technical purpose in Afghanistan, we didn't had what you can say, any perfect teacher to learn us about the designing of it. But I tried hard to use these things, these materials, and it make it very strong, and it's very strong. And I use the EMG sensor, electromicrowave technology, and also some Arduinos. And also there is another picture I want to show you once. Wait a minute. Sorry. for that. 1 minute.
No problem.
Let me show you the video of the using this material for you. Do you have?
Yes,
Here we are. Good.
Yes.
that's awesome.
He
That's-
can, he named Farhad, and he was my friend. I promised to him that I will make a hand for you, and I tried very hard, and now it's the second version that I have made. He can do.
And, the bicycle chain is a brilliant innovation.
Oh yeah, awesome. It must be very strong, very sturdy.
Yeah, it had a problem on the pressure controlling, and I solved it by using some what we can say. Unfortunately, sorry for my English. It's not my native language. And let me show you the controlling of the pressure in the system. Can you see? I use this
Yes.
one.
Yes.
Yeah, it can control the pressure. It doesn't have on that video. It doesn't have this one. Now I made this thing. It's new, and when you want to take like this one, you can take it. It's very strong servo. See,
Yeah.
all fingers are. Yeah. This
Got it.
is the structure.
That's nice.
Yeah. I used Arduino there. Arduino varies some powers for the servo and to make the servo power ready, 6 volt. And just I used the 3.7 volt battery and some adapter, some booster for it to make the power of it. I think it's very ready to use for the people, yes. And this was the second generation. This is the first generation that I had made for
Yeah.
Mr. Zakaria. Yeah. It can also work. Unfortunately, it doesn't have charge.
I believe you.
I was
Very
not
nice.
really.
One of the
Hmm.
One of the wonderful things about your design, besides the simplicity, one motor and the robust mechanic, is
Yes.
that with that spring, it's going to be a conforming grip. It will
Yeah,
shape
yeah.
itself to the object being
Yes,
gripped.
shape itself. Yes. It's because of shaping the shaping for material. When you want to give something, it can shape for any shape that there was. And this is the first generation that I was made. Let me show you 1 minute. That's all. 1 minute. So sorry,
Take your
I
time.
was on the way because of something, this one. You can use,
Mhm.
yeah.
Now that's another question. How does that feel from?
I used from the simple disabilities. We can use EMG sensors, electromagnetic sensor for the reaction of muscles, these things. But because of pricing, because of some poverty in there. I use from very tiny disabilities. My friend hand was cut, but there was something that
He could move.
it could move. It could move, and I used from it, and some limit switch, some access for him, and he was very smooth. It was very smooth for him to use it. Yes.
Yeah, by the way, those of the people who are not living in poverty situations typically find that EMG doesn't work very well anyway. So I think you're on the right track.
Yeah. Yeah, but there is some EMG sensors, but the cost is very about $1,600, $1,700, $1,700. That there is EMG sensors, but I think also to use from tiny disabilities that they have, from any movements that on their disability, we can use for just one click. And I think it's not important to move each fingers. Just we can use it like this, make it like this. To use it's what was my outcome? My research, my experience in this 3 years. I thought that we can use it like. We can make it the hands to shape like this one, this shape. It is very, it can very be smooth, sorry for my English.
It can be a very smooth movement.
Yeah, movement and usable, by this frame, the person can give anything, in any movement and any shapes.
Yeah, it's the most important movement. You
Yeah,
don't really need, but this you always need. Yes.
Yeah.
That's great.
Can-
That's awesome.
Can you give us a close look at the chain and the cables that you use?
This one.
Yes.
This is the chains. This is the silicone that I have
Okay.
used for the
Interesting.
yeah.
Fingertips.
And
Yeah.
Very nice.
yes. Yeah.
Slow down. Slow down. And
Here.
okay, so
These
the
are the limited because of bicycle chain. These.
I see.
Yeah. These are the limited. These are the springs. We can
Yes.
see. What we get springs because of controlling the pressure.
Sure.
For 40 kg servo, Arduino, a power booster, and a battery. And there is a switch, limit switch, and that we can put on the any movement of any small movement in the disabled, those who have disability. And I think you have saw the people that there is any movement. I think you see the always there or some movements on their hands, I think.
Sure.
Yeah.
I'm just thinking, I think it's a very promising and radical new approach. And I'm just thinking about with 3D prints, you can provide a design and it's clear to people what they need to do. They just need to get it into the printer and print it. In this case, it looks like you did a lot of soldering and welding in order to make everything work.
Yeah. But what I think, it's important to make it very strong. the 3D printer is also they are good to make it strong, but what is accessible for the peoples, like Afghanistan, India, my company, I had run a startup by the name of Masa Technology. We were the first company that import the 3D printers in Afghanistan in 3 years. There was, but 99% of the college universities didn't saw the 3D printers from the near, and they didn't have any access to this thing. And also the materials like 3D, 3D printers, 3D technology is very robust, but for us, it's very new. Because of these societies, we need to make these shapes of hand, make it very strong, accessible materials, and very simple, I think.
So what is your plan for the future, Mazhar?
I'm trying to make to camp for a good product. I will make it like this ship, as you see in this, and make it make it a final product. After that, I will do you have my voice?
Yes.
Okay.
Yes, we hear you.
After that, after the completing the final of this one, for tonight, I will also working on the third generation of this robot to make it very strong, to make it perfect. I will search. I will do it better for the future. Yeah.
And your customers are your friend, or you're hoping to make it available to people all over Afghanistan?
My customers, I may, when the story is very, very good. I will tell you. One of my friend, Mr. Zakaria, he was our trainer. He lost his hand because of mines when he was 7 years old, and he's very strong in wrestling, and he was our trainer on wrestling. When I was in school, and I tried to make DIY projects very, but when was in 11 degree of school, I promised to him that, hey, Zikriya, I will make a hand for you. After 4 years in university, when it was during my studies and during my DIY projects, I tried to make a hand. It was very simple for me, just as another DIY projects. When I implement my project to the Mr. Zakaria, I saw his field. It was very another feeling for me. I can't say, for you another word for me. After that, I promised to myself, I will make a complete version of this hand, not just for Zakaria, for all those who lost his hand or legs or his limbs, to make them happy, make them the physical accessibility and other things. And I start from university. I run a startup, and we have some sponsorship from UNDP Afghanistan, from EU delegation in Afghanistan. and try to try to introduce this project for World Bank group in Afghanistan to WHO in Afghanistan. I tried really hard to make, we had a meeting with the ICCRC, and there, this is the product of them that they are provide for the peoples. There is much people that they are come for me. They have this one, but they say, please make it one of these things
Sure.
for me also. And I'm trying to make it better, but unfortunately, some problems like financial problems is very a big wall for us. For me, there is not like any other countries like developed countries like there is on their university like in MIT or another universities, they have their budgets for the students,
course.
banks. Yes, there is no. I working for the day, penny. I will collect the money. After that, I will give the materials like this. It's a little hard, but very hard to make materials. After making the materials or making money for materials, we have short time to make it. The financial problem and also the lack of professionals problem make our time very hard to make this hands or make the developments on the robotic hands.
Well, you may have a really solid and strong solution that could benefit a lot of people. But I don't see yet how you can make many of them, because right now it's a handcraft. Now it's not digital technology, but it looks to me like the metal, the limiting soldering that you're doing.
Yeah.
That's custom work. Everything else I could imagine lots of people learning how to do. Have you thought about some mechanism that would be easier to?
I have thought about the mechanism to control the limitation, but we don't have CNC machine to laser cut the materials, the aluminum to make this, the alternative of this one, bicycle chain. It's an alternative case. We have, I tried to design some mechanism for the controlling this ship, but laser cutting have cost, and we need to have a laboratory. But what I think, I need the help for the mechanism of this robotic hand. What I suggest for the e-NABLE organization, we can use 3D printers, but one of the second generation of hands, a little complicated. We can design something like this one, bicycle chains. With CNC, we can design the parts of iron things like for this hand. For the hand, it can be very strong. Anyone, those who have access for CNC, they can make it. It will be waterproof. We can, something like this. I think it's good to work on a product, and strong product. My suggestion, if there is
Well,
any not misunderstanding.
we will remain interested, and
Uh-huh.
I think it's a very interesting thing that you've done. Um, it if you have ideas for the limiting material, 3D printed, or something that can be laser cut, I could imagine that Americans might do the laser cutting and send you that part. I don't think the e-NABLE community has a lot of people with CNC machines, but I would imagine some of them do have access to laser cutters, if that's a way of doing it. Or 3D printing just the piece that would act as
Limit.
the rate limiter.
But what is my suggestion? No, not for bring me the materials to limit switch. For all things that enable community, I think they should work on a design. You know, what? Wait a minute. For a design. For a unique design on that is CNC, with laser cut machines, specifically with the specifically using for the iron. Okay.
Say that again, please. Specific.
Specifically, we can enable community will work on a design that laser cut the material with the iron material. Okay, we can make there is on internet some designs that they're make it with the metal and laser cutting the fingers.
Laser. Mm-hmm.
Yeah.
I would love. Well, listen. So you should put a post in the hub. I don't know anyone offhand who has that skill, but there might well be. I think you should make a very clear request to the e-NABLE community on the
Okay.
hub and on
Okay.
Facebook, describing the kind of partner you need and
Okay.
explaining why it's so important. The notion that if you only had that component, then Afghans who know how to deal with bicycle chain and mechanics could begin producing these in quantity is a very attractive proposition.
Yeah, I'm trying to find an engineer or those who has this knowledge to make a design for me, a design of the fingers, the alternatives for the bicycle chain.
Xavier, I'm a little bit fascinated by these mechanical joints that you've made, but it seems to me that if those mechanical joints could snap into the gaps in the bicycle chain and the hinges had the right limiters, maybe you could do something along those lines, that they would just pressure fit in, but then they would limit the fingers from flopping open the other way.
I used some laser, welding on there, laser welding, but it's very strong,
I'm sure it is very strong. That's right. But we don't know how to accelerate that.
Yeah.
Unless you can train lots of people to do it.
But as a product for a factory, we can do it.
Okay. Well,
Not,
please keep it.
if we make it for those people who want to make it by self, I think it's hard for them. 3D printing is easy, but this is a strong for there. For our situation, I think it's good to make a strong thing, because
Yeah.
the peoples, because of their, what we can say, they're too
They're doing hard work.
yeah, yes, doing hard work, too angry for any tiny they're fighting very soon for any gaps. Yes.
Understood. I do understand.
So sorry. So sorry for
Yes.
misunderstanding about my English. I'm a little not good for talking.
It's better than my Urdu.
Better than my Afghani or anything.
It's been a great meeting and fascinating work from both of you. It's an interesting contrast. There's some interesting potential complementarities. You'll notice that, at this stage of my life and from where I sit, the pressing question is, how do we make it actionable and available? And as research projects, however, they're both really wonderful work. Thank you.
Thank you.
Thank you.
It's great work. Thank you. Thanks for taking the time.
Thank you for
It
arranging
must
this,
be-
Vivek.
And late in Afghanistan. Oh, thank you, Sarah, for finding these folks. All right.
So until we meet again, keep us
Okay.
posted, everybody. Bye.
See you.
Okay.
Bye-bye. Thank you.
Bye-bye.
Bye.
Bye-bye. Thank you.